Okay, so good afternoon. So this is a lecture video about aldehydes and ketones. So for our outline, we will be naming some aldehydes and ketones. We will be drawing some structures and we will go into the properties of these aldehydes and ketones. So to start, aldehydes and ketones. Aldehydes with a functional group of RCHO and ketones with R2CO are characterized by a carbonyl functional group. So it is symbolized by this C double bond O. So these compounds occur widely in nature as intermediates in metabolism and biosynthesis. So we have here two examples, pyridoxal phosphate and hydrocortisone. So pyridoxal phosphate is the active form of vitamin B6, and it is an important coenzyme in some biochemical uh, biochemical biochemical reactions. On the other hand, you will see here hydrocortisone. So this one is a steroid and it is also a hormone, and you will see here some of the this part, that oxygen with a double bond. So this is a C double bond O, and a and this is the carbonyl group. So that is a carbonyl group. So what is the structure of these aldehydes and ketones? So for aldehydes, the functional group of an aldehyde is a carbonyl group that is bonded to a hydrogen atom. So remember that C double bond O, and one side of that carbon is bonded to H, and this other part is bonded to R. So this R can be any substituents. Okay? So in methanol, the simplest aldehyde, also called as formaldehyde, the carbonyl group is bonded to two hydrogens. So the structure of methanol or your formaldehyde will be C double bond O H H. So we have here CH2O. So that's methanol or your formaldehyde, or commonly known as your formalin. So in other aldehydes, it is bonded to one hydrogen and one carbon group. So this hydrogen can be replaced by a carbon, so a series of carbon chain. So it varies dun sa length. So on the other hand naman, the functional group of a ketone is a carbonyl group that is bonded to two carbon groups. So for example, um, our best known example of a ketone is your acetone. Yung ginagamit natin sa panlinis ng ating kuko. So whenever yung mga girls meron sila ng cutics, so pantanggal doon is acetone. The systematic name or the IUPAC name of acetone is propanone. Okay. So how do we name aldehydes and ketones? So aldehydes are named by replacing the terminal E of the corresponding alkane with al. So take note, your E, di ba yung mga alkanes natin, they end with E, like hexane, pentane. So you will replace the ending E, with al. So magiging name dito is methanol, ethanol, butanol, propanol, and so on. So the parent chain must contain the CHO group, and this CHO, the carbon in that CHO is numbered as C1. So you will start the numbering at the C double bond O. So if the CHO group is attached to a ring, you use the suffix carbaldehyde. So we have here some examples. So like this one. So you have only one carbon here. So that's name is methanol. You have two carbons here. So that's ethanol. And then this one is meron siya namang double bond. So the name is supposedly propanol. So di ba it's propane. So we drop the E, it will become al. So that becomes propanol. But since we have here a double bond, it will become propene. So you drop the E, you make it al. So propanol. Okay? So it becomes propanol. And then we have here two butanol, and for this one, this is familiar with you because we discussed last time aromatic compound. So this one is a benzene ring, and there is a CHO group. So this one is a benzene na aldehyde. So that's why its name is, common name is benzaldehyde. But the systematic name of this is benzene carbaldehyde. So for unsaturated aldehydes, you indicate the presence of the carbon-carbon double bonds by changing the ending of the parent name alkane from ane to enal. Kasi nga, 'di ba, the ending lagi ng mga mga alkenes natin ay "-ine", 'di ba? From ane, pag ane is single bond, pero pag may "-ine" ka na, double bond. So yung "-ine" na yan magiging "-enal". Okay? And also the numbering of the carbon chain always begin with the aldehyde carbonyl carbon. And you show the location of the carbon-carbon double bond by the number of by you show the location of the carbon-carbon double bond by the number of its first carbon. So, for example, the carbon-carbon double bond, of course, between 3 and 4. So, ang gagamitin mo lang is the number 3. Okay? So, we have here the IUPAC system, and some names will be retained for the common names. So, for example, like these aldehydes, we have here, this one is cinnamaldehyde. So if you're familiar with cinnamon, or if you know cinnamon, so the name of the compound is trans 3 2 propanal. So paano pinangalanan paano pinangalan yung compound na ito? So you have here 1, 2, 3. So met et prop. So that's why it's prop. Supposedly it's propanal. But since you have a double bond between 2 and 3, so that will become 2-propinal. Okay, so acknowledging the fact that you have a double bond between 2 and 3 carbon. Then we have here a an aromatic group. So this aromatic group is your phenyl. So that's phenyl. So where is the location of the phenyl group? It is attached to the third carbon. So that's why it's 3-phenyl 2-propanal. Why is it trans? As you can see, the aromatic group, the aryl group that is located on opposite side. So opposite side itong benzene ring na to and this one. So that's why it's called trans. So this one is the most common. This is your benzaldehyde. Then this one is, it looks like benzaldehyde, but there is this one OCH3. So this one is a methoxy group. And then this one is a hydroxy group. But for this common name, this is all also referred as your vanillin. And the name comes from vanilla beans. Okay. So how about ketones? So for ketones, the terminal E of the alkane is replaced by -one. So ano yung mga namings natin? Like the namings will be hexane, hexanone. We have pentane, pentanone. So the parent chain is the longest one that contains the ketone group. Okay? Dapat laging kasama doon sa dapat laging kasama yung C double bond O doon sa parent chain. And the numbering begins at the end nearer to the carbonyl carbon. So ito na naman yung magiging situations natin. So like for example, this one, you have a 6 carbon chain. So if you start here, you will encounter the C double bond O at third position. But if you start here, this is 1, 2, 3, 4. So we should give um, the the smallest number or the lower number doon sa C double bond O. So that's why it's 3-hexene hexanone. Okay, why is it hexanone? So acknowledging the fact that it's 6 carbon long, tapos dahil meron kang C double bond O dito, magiging one siya. Hexane, hexanone, and the 3 here refers to the position of the C double bond O. Okay, how about this one? So, mapapansin nyo, dito, nagkaroon naman ng double bond. So, paano ang gagawin natin? You will also start kung saan yung mas malapit yung C double bond O. So in this case, this is the end nearer. Okay? So we will start numbering here. So this is 1, 2. So we encounter the C double bond O at the carbon position 2. Then as you go along, you will encounter a double bond between 4 and 5. So how do we name this? So the parent chain is also 6 carbon long, meaning it's hexene in nature. Hexene siya kasi meron siyang double bond. But since you have a ketone here, you drop the E, you make it on. So hexenone. Okay? Hexenone siya. But we need to indicate where is the position of the double bond and the C double bond O. So in the old naming, it's 4 hexene 2 on. The 2 here, yung number dun sa loob ng parent name, this is the position kung saan nandun yung double bond. So 2 on, ibig sabihin nun, the C double bond O is at carbon position number 2. And then the 4 here, it means the the carbon-carbon double bond is between 4 and 5. So only 4 lang naman yung gagamitin natin. So that's why it's 4 hexene 2 on. Or the new name is hex 4 in 2 on. Okay. Now we have here a case wherein nagiging dalawa na yung C double bond O mo. So we call this your dione. Dione. So, dione siya, meaning meron kang dalawang carbonyl groups. So, again, you always start with the end nearer, the C double bond O. So, this is the part na yon. So, you start numbering from your right to left. Again, you will encounter 6 carbons, so that's why it's hexane. But this time, since you have two carbonyl groups, you will use the term dione. Now, what is the significance of this 2 4 number before the name of the parent chain? So the 2 4 refers to the position of the two ketone groups, the C double bond O. So another the new naming here is hexane 2 4 dione. So there are also other examples in this slide. So we have here acetone, a very well-known ketone. Then we have here 5-methyl-3-hexanone. So tingnan natin bakit naging ganun yung naming. So again, we will encounter first the C double bond O if you started from this side. So 1, 2, 3. So that the C double bond O is at 3, carbon position 3. That's why it's a 3-hexanone. Why is it hexanone? Kasi yung parent chain mo ay 6. And since ito naman ay fully saturated, wala naman double bond, so that's a hexane. That's a hexane. You drop the E, you make it on. Hexanone. Now, you have a substituent at position number 5. So what is that substituent in carbon position number 5? That's a methyl. That's why the naming here is 5-methyl 3-hexanone. Next, we have here a cyclohexane. So cyclohexane yan. So originally that's a cyclohexane. But since you have a C double bond O dito, you drop the E, you make it on. That's why it's a cyclohexanone. Now, sabi natin, the C double bond O is usually the carbon number 1. So, you decide if the your direction will be counterclockwise or clockwise. So, meron ka ditong substituent. This is a methyl. So, this methyl substituent should be given a smaller number. So, if you start here, it will become 1, 2, 3, 4, 5, 6. So, 6 siya. But if you go clockwise, so you will encounter the methyl group at carbon position number 2. So, that's why the name is 2-methyl cyclohexanone. So, this is retaining some names for some ketones. So we have here acetone. If you if you remove, or if you replace this part with a benzene ring, so with a benzene ring, it becomes an acetophenone. But if you replace the two sides by a benzene ring, it will now become a benzophenone. Okay? So ito naman, mga additional lang to, if your aldehyde or ketone contains an OH, or we called it an hydroxyl group, or an NH2, or an amino group. So again, you will number the parent chain to give the carbonyl carbon the lower number. So yung C double bond O, dapat ma-encounter mo siya with a smaller number. You indicate the OH substituent by hydroxy. So OH here is hydroxy. And the NH2 substituent, we call it an amino. Now, hydroxyl and amino substituents are numbered and alphabetized along with other substituents. So, anong laging mauna dyan? So, if you have an amino and hydroxy, ang mauuna dyan is yung amino, followed by the hydroxy. But, for example, if meron ka namang hydroxy versus methyl, you will start with the hydroxy, followed by the methyl. So, let's give some examples here. So, assuming that you hindi nyo nakikita yung naming dito, so again, you start with the naming of the parent chain. So we have here, this is the carbon position number 1 because you have here the C double bond O. So you have 1, 2, 3, 4, 5. So that's why it's a pentane, supposedly. Pentane. But since this is an aldehyde, you will drop the E, you will make it al. That's why it's a pentanal. So dito sa situation na to, na establish na natin kung saan yung carbon number 1. So pwede na nating bigyan ng number din yung other substituents. So what are the other substituents here? We have OH and we have here a methyl. So anong mauuna dito? Ang mauuna dito, class, is yung hydroxy followed by the methyl. And since we have established the direction, the OH or the hydroxy group is encountered at carbon position number 3, while the methyl group is encountered at position number 4. That's why the naming is 3-hydroxy 4-methyl pentanal. How about this one? So what is this compound? Is it an aldehyde or a ketone? The key difference here is if it ends with an H, that's an aldehyde. But if it doesn't end with an H, that is automatically a ketone. So, this one is a ketone, an organic compound ketone. So, how do we name this organic compound? Again, you start with the parent chain. So, we have 1. So, again, yung rule dun is yung C double bond O should be given a smaller number. So, dapat hanapin nyo yung N kung saan siya mas mababang mabibigyan ng mas mababang number. So, in this case, it will start again at right to left. So, you will encounter the C double bond O at carbon position number 2. Ano pa yung makukuha nating information dito? The parent chain is 1, 2, 3, 4, 5, 6. So, you have here a hexanone. Originally, that's a hexane. But since hexane siya, kasi wala namang double bonds. So, you drop the E, you make it own. Hexanone. Okay? Hexanone. Now, na-establish natin yung direction. So, you start the numbering from your kanan to kaliwa, and you will encounter several substituents. You have an amino, an NH2, and then this one is met-et, so an ethyl group. So, meron kang alphabetization, ethyl versus amino. So, based on alphabet, you will start with an amino substituent. So, amino first, then ethyl. Now, where is that amino group? The amino group is at carbon position number 3, while your ethyl group is at carbon position number 4. That's why the name will be 3-amino 4-ethyl 2-hexanone. I hope na gagets nyo yung sinasabi ko dun sa mga rules na na sinusunod na natin in the nomenclature. Okay, how about what if gamitin natin yung mga ketone group and your aldehyde group as a substituent. So siya na naman yung gagawin nating substituent. So we call this originally, di ba class, that is RC double bond O, pwede itong H. If this is an H, this is an aldehyde. But if this is an RCO R, so itong part na kasing to, pwede nating alisin yan. So matatirahan ka lang ng RC double bond O, and ito naman, alisin mo yung R group. So it will also become RC double bond O. So this remaining portion, we call that your acyl group. Okay? So tatanggalin natin siya. So this one is your RC double bond O. So RC double bond O is generally called an acyl group. But yung R kasi dito, pwedeng maiba-iba yung carbon dito. So like for example, if you added another carbon here, so meron ka ng met-et. So um, actually, yung common name yung ginagamit dito. So ginagamit dito. So this one, it will become your acetyl group. So if this one is H lang siya, this is called your formyl group. Remember, di ba yung ating formaldehyde, HC double bond OH. Pag naalis yung H dito, this is a formaldehyde. So pag naalis yung H, it will become formyl. Okay? Okay. So ito naman is your benzyl, 'di ba? Supposedly kung ito may H, that's a benzaldehyde. But since you remove the H, it will now become a benzoyl group. Okay? So ito naman, the prefix oxo is used if other functional groups are present and the doubly double bonded oxygen is labeled as a substituent on a parent chain. So, paano natin siya nini-name? So, 'di ba? Mukha siyang dione siya. Hindi siya dione kasi ang dione ay nagwo-work lang kapag ito ay may itong part na to ay also carbon. But since this is not attached to carbon, another carbon, so this part is just an aldehyde. So, how do we name that? So, this is named as your, referring to this is your carbon position number 1 because you have the C double bond O. So, how many carbons are there in the parent chain? So, 1, 2, 3, 4, 5, 6. So, this one is a hexane. But since this is an aldehyde, you will convert the A of the hexane to al. So, it will become hexanal. Now, you have an extra oxygen at carbon position number 2. So, that will become a 3-oxohexanal. So, for the common names of our aldehydes, so the common name for an aldehyde is derived from the common name of the corresponding carboxylic acid. So you will drop the acid and change the suffix ic to oic. You drop the acid and change the suffix ic or oic to aldehyde. So again, you name each alkyl or aryl group bonded to the carbonyl group as a separate word, followed by the word ketone. So alkyl or aryl groups are generally listed in order of increasing molecular weight. So when say increasing molecular weight for the ketones naman, kung sino yung mas mahaba na, kasi 'di ba pag mas humahaba yung chain, mas bumibigat siya. So inililista natin siya, ang mas mauna yung pinakamaliit, maliit muna pa laki. So increasing molecular weight. So let's give an example. This one is your acetaldehyde. So yung talagang ano niya, um, ito kasing yung, 'di ba? Alam niyo naman class, yung mga C double bond O natin, yan ay malaking group yan kasi we're just starting. This is one is your carbonyl groups will give rise to different functional groups. So itong C double bond O na to, pag nakatouch lang yan sa H, that's an aldehyde. But if you attach the C double bond O sa magkabilang side ng may C sila, so that will become a ketone. Now, there's another functional group with a C double bond O but with the OH. So this one is called your carboxylic acid. So pag yung carboxylic acid mo na yun, tinanggal mo yung OH na yan, so yung naming doon is also just the same sa atin dito. Diba, this one is a carboxylic acid. Diba? Take note, carboxylic acid. So kaya, tinatanggal yung acid, tanggalin natin yung ic o yung oic at papalitan natin siya ng aldehyde. So an example is your acetic acid. So meron dyan dalawang carbons with an oxygen. So yung acetic acid natin ay CH3, C double bond o OH. So pag inalis mo yung OH na yan, palitan mo siya ng H, it will become an aldehyde. So ano yung common name nitong compound na to? This is acetic acid. So you drop the name acid, you drop the ic, and then you replace the ic with aldehyde. So what will be the name? Acetaldehyde. So okay. So acetaldehyde is dalawang carbon siya. So acetaldehyde. So now for ketones naman, nililist na natin siya in increasing molecular weights. So, paano natin siya ililista? Yung ketone, yun yung dulo. Okay. Now, we list the substituents or yung bawat nakaka-attach doon separately. So, this part is 1, 2. So, dalawa yan. So, this one is an ethyl. How about this one? Ito, isa lang to. So, this one is a methyl. So, we arrange the methyl versus the ethyl. Methyl comes first kasi mas maliit siya. And then this one is your ethyl. That's why this one is called your methyl ethyl ketone for the common name. Now, how about this part? So, again, this is a ketone because your C double bond O is connected to two different carbons. So, how do we name this part? One is met-et. So, this one is ethyl. And then this one is your isopropyl group. So, the isopropyl group versus the ethyl, anong mas maliit? Yung ethyl, yung maliit. Kaya, mauna siya sa naming. So, this one is ethyl isopropyl ketone. So, that is how you name your common name for your aldehydes and ketones. So, we have here an example. So, we draw the structure for 3-methyl-butanal. So, ano yung makukuha natin mga information dito? So there is a metal group at carbon position number 3. We have a butanal. So ano ibig sabihin ng butanal na yan? Yung al na ending, it means this is an aldehyde. An aldehyde yan. How about the butan? So it means we have met et prop but. So meron tayong apat na carbons. Okay. So 4 carbons yung ating parent chain. So, paano natin siya i-drawing? So, you always start with the structure. So, drawing tayo ng apat. So, dito, sa carbon position number 1, nandyan yung O. And since this is an aldehyde, the ending is just H. Now, this one is carbon 1, 2, 3, 4. So, at carbon position number 3, you have a methyl group. So, this one is a CH3. So, you just add the remaining substituents. So, this one is carbon number 1, hindi yan bond. So, lagay natin siya. So, we have your CH3, CH3, CH, CH2, C, double bond O, H. So, tama ba ang aking winowing? So, we have the CH3 that is bonded to a CH. Dun sa CH na yan, may nakaband na CH3, CH2 this part, and then the CHO. So itong C double bond O, yung C double bond O H, this can be simply referred as your CHO. Okay? So now for some properties of your C double bond or your carbonyl group. So your C double bond O bond is polar. So bakit siya naging polar? If you could still remember our electronegativity differences, oxygen is more electronegative than carbon. So, electronegative, si oxygen. So the oxygen will bear a partial negative charge. Kasi mas attracted si oxygen dun sa mga electrons. Kaya nagkakaroon siya ng partial positive, partial negative charge. While dahil nagkaroon ng partial negative charge yung oxygen, yung carbon mo magkakaroon siya ng partial positive na charge. That's why your aldehydes and ketones are polar molecules. So in this figure, you will see the polarity of your carbonyl group. So when say polarity, there is an equal sharing of the electrons. Though sinasabi natin 'di ba ang mga covalent bonds ay uh, nagre-result from the sharing of the electrons. There will be times that the element will have a greater affinity dun sa electrons na yon. So kaya parang hinihigit niya papunta sa kanya yung mga electrons. So that in electrostatic map na katulad nito, yung mas negative yung mas negative yung charge, it is symbolized or sinoshow siya with the red, and yung partial positive is the bluer region. So the blue here is the partial positive, and then the red one here is the partial negative region of that molecule. So in liquid aldehydes and ketones, there are weak intermolecular attractions between the partial positive charge on the carbonyl carbon of one molecule and the partial negative charge of the carbonyl oxygen of the another molecule. So, di ba, dahil nga nagkakaroon tayo ng partial positive at partial negative dun sa molecule, yung partial negative na yan ng oxygen will be attracted to another molecule, and yung partial negative nitong side na to will be attracted to the partial positive carbon. Okay? Again, the partial negative oxygen, partial positive charge na oxygen will be attracted to the partial positive carbon of another molecule. Okay? So, and vice versa. So, there is no hydrogen bonding. No hydrogen bonding is possible between aldehyde and ketone molecules. Why? Because hydrogen bonding only occurs if your H is bonded to very electronegative elements like N, O, and F. So, kaya yung water natin, diba, it's HOH, this will be attracted to another water molecule. It's because yung, ito, yung oxygen dito, that will be attracted. Kasi itong oxygen dito is partial negative. Then, dahil ito ay partial negative, itong dalawang hydrogens dito is partial positive. So, yung partial negative na oxygen dito sa isang molecule na to will be attracted to this partial positive hydrogen of another water molecule. But since your oxygen is bonded to a carbon, so hindi siya mangyayari. And aldehydes and ketones have lower boiling points than alcohols and carboxylic acid. So, compounds in which there is hydrogen bonding between the molecules. Okay? Say, yung ating alcohols and carboxylic acid, remember that alcohols, ang ending nila is OH. Mayroon silang OH group. Yung carboxylic group naman natin is C double bond O na may OH. So, these OHs can participate in hydrogen bonding. But your aldehydes and ketones, wala naman silang feature na OHs dyan. So, hindi sila participate in hydrogen bonding. So, these are just the boiling points of the 6 compounds of comparable molecular weights. So, we have here your butanol and the 2-butanone. So, ito naman yung alkane. So, this one is the alcohol. This one is your alkane. So, yung aldehyde at yung ketone, ano napapansin natin sa kanila? Yung boiling point ng alcohols ay for the same number of carbons ay mas mataas yung boiling point for the alcohol. Dun sa ating aldehyde and ketone, medyo mababa. So formaldehyde, acetaldehyde, and acetone are Another characteristic nila is infinitely soluble in water. So they are soluble in water. Your formaldehyde is just your H, C double bond O, H. Your acetaldehyde is CH3, C double bond O na may H. And your acetone is your CH3, C double bond O, CH3. So, ito na, dahil maliit na molecule lang sila ay soluble in water. But aldehydes and ketones become less soluble in water as the hydrocarbon portion of the molecule increases in size. So napansin nyo dito, yung formaldehyde isang carbon lang siya, yung acetaldehyde dalawa, at yung inyong acetone ay tatlong carbon, but the ketone functional group, sila ay soluble in water. Pero pag humahaba na yung chain, like for example, itong acetaldehyde, lagay mo siya ng 2 to 3 carbon chain longs pa sila. So, humahaba yung hydrocarbon. Humahaba yung hydrocarbon. So, itong hydrocarbons na to ay hindi sila soluble. They are not soluble in water. Simply because, di ba, nasabi ko na sa inyo to na ang mga hydrocarbons ay nadidissolve lamang dun sa katulad nilang mga non-polar. Yung hydrocarbon chain na yan is non-polar. But your water is polar molecule. So, your non-polar substance will not mix with a polar substance. So, habang humahaba yung hydrocarbon chain ng isang molecule, uh, nagiging less soluble sila. And that ends our discussion for aldehydes and ketones. Thank you very much.